A lock stitch is the most common mechanical stitch made by a sewing machine. The term single needle stitching, often found on dress shirt labels, refers to lock stitch. Structure. The lock stitch uses two threads, an upper and a lower. Lock stitch is so named because the two threads, upper and lower, lock together in the hole in the fabric which they pass through. The upper thread runs from a spool kept on a spindle on top of or next to the machine, through a tension mechanism, through the take-up arm, and finally through the hole in the needle. Meanwhile, the lower thread is wound onto a bobbin, which is inserted into a case in the lower section of the machine below the material. To make one stitch, the machine lowers the threaded needle through the cloth into the bobbin area, where a rotating hook catches the upper thread at the point just after it goes through the needle. The hook mechanism carries the upper thread entirely around the bobbin case, so that it has made one wrap of the bobbin thread. Then the take-up arm pulls the excess upper thread back to the top, forming the lock stitch. Then the feed dogs pull the material along one stitch length, and the cycle repeats. Ideally, the lock stitch is formed in the center of the thickness of the material, that is to say, ideally the upper thread entwines the lower thread in the middle of the material. The thread tension mechanisms, one for the upper thread and one for the lower thread, prevent either thread from pulling the entwine point from out of the middle of the material. Geometry. The geometry of the lock stitch is controlled by the presence or absence of sideways movements of the machine's needle, and backwards movements of the machine's feed dogs. In older machines, the needle and feed motion is controlled by mechanical cams. Some modern household machines offer a slot for user-replaceable custom stitch cams. In more recent designs, the needle and feed motion are directly motorized. Straight stitch geometry is produced when the needle has no sideways movements and when the feed dogs are following only in the normal forward-4 motion movement. Because its two threads run straight and parallel, a straight stitch is not natively stretchable. Zigzag stitch geometry is produced when the needle moves rhythmically side to side while stitching, while the feed dogs are following only in the normal forward-4 motion movement. Most lock stitch machines made after the 1960s are capable of doing this. Older machines achieve the same stitch with a specialist presser foot which moves the fabric beneath the stationary needle. Zigzag stitches are used when a stretchable stitch is required, such as when sewing stretchy fabrics. Blind stitch geometry is a derivative of the zigzag. It is created in the same manner, except that the needle zags to the side and then zags back only once every fourth or fifth stitch. It is used to reduce the visibility of hems and other seam edges. Stretch stitch geometry is specifically for stretchability. While the needle is moving, as for straight or zigzag stitches, the feed dogs automatically move the fabric forward and backward. As with zigzag stitches, stretch stitching is controlled by mechanical cams, but because of the dual action, stretch stitch machines have double cams. As the double cam rotates, the first follower rides along one track to move the needle bar from side to side, while the second follower rides along a different track to move the feed dogs forward and reverse. Decorative by adding controlled motion of the material being sewn through an additional set of motors, arbitrary customized patterns of 100 cm or more in each direction can be sewn, opening the door to the very popular category of programmable household embroidery machines. Prevalence. Most home sewing machines are lock stitch machines, although overlockers have entered the home market in the past 10 years or so. Industrial. Of a typical garment factory's sewing machines, half might be lock stitch machines and the other half divided between overlock machines, chain stitch machines, and various other specialized machines. Industrial lock stitch machines with two needles, each forming an independent lock stitch with their own bobbin, are also very common. There are different types of lock stitch industrial machines. The most commonly used are the drop feed for light and medium duty, and walk-in foot for medium and heavy duty like the Class 7 with an impressive 3/4 foot lift. This makes the Class 7 able to stitch through heavy materials up to 3/4 with threads as strong as 57 pounds. originally made by Singer in the US and Europe for supplying the demand of heavy-duty clothing for the troops. For many years after the war this class was not available as new because their market was filled. With the outsourcing of many sewing manufacturing jobs, nowadays many Chinese Class 7 machines are available and built by federal specifications giving them equal performance to the original ones. Most industrial lock-stitch machines sew only a straight line of stitches. Industrial zigzag machines are available, but uncommon, and there are essentially no fancy pattern stitching industrial machines other than dedicated embroidery and edge decoration machines. Even something as simple as a bar tack or a buttonhole stitch is usually done by a dedicated machine and capable of doing anything else. When a variety of decorative stitching is required rather than a single stitch, a commercial machine is usually employed. References. See also, chain stitch, overlock, sewing, sewing machine.